Okay, good morning, everyone. We can get started. I think most everybody's returning, but for those of you who don't know, I am Ali Kovash. I'm a marketing specialist here at Steffes. And today, Al is going to take you through some residential applications for Steffes ETS heating systems. Just so you know, you'll be on mute today, and any questions you have, you can enter them in the Q&A section at the bottom of your screen. And I'll keep an eye on those, and I'll ask them to Al at the end of the presentation. So with that, Al, you can take it away.
Thanks, Ali. You can hear me okay? All right, excellent.
I believe so. I can hear you.
All right, this is the part in the presentation where, oh, there we go. Okay, so we're going to talk about residential applications today. My name is Al Tockley. I'm the product manager for our heating products division. And again, we're going to be looking at our residential applications as we go through today. So when we look at our residential product, it all started with room units back in 1986. We were working with some of the local utilities, came to us and said, you know, can you make ETS heaters like these European heaters, but we want some changes. We'd like to have more insulation. We'd like to have bigger fans. And of course we said, yeah, we can do that. And we started our ETS journey then. And our first systems were installed in 1987. And we have about 80,000 systems installed across North America since then. The nice part about room units is they're easy zoning. And I guess by definition, they're going to be a heating appliance in the room that they're in. And so you don't need to have, duct zoning or hydronic zones, things that can cause complication and extra cost to a heating system. We'll talk a little bit about that moving forward. When I think about room heaters, I always talk about comfort. It's the one thing that our customers tell us. I think it's always an expectation when you buy a new heating system that's going to make you comfortable. But room heaters take that to another level, and so it is something that if you can get testimonies from people that have ETS systems, that's one of the things that they'll talk about. And then, of course, our room heaters are 2100 series, and we've been making those for 20 years now. So there's been very, very minor updates over the years, but we've had really good success with that product line. So you can see a picture of one of our 2100 series room heaters. Things to be concerned about, clearances. It's important that we maintain clearances around the heater. That's 4 inches on top, 2 inches on the side, 1.5 inches in the back that's maintained by the wall support bracket, and then 15 inches in front. And when you're looking at those clearances, one of the things is that we say 4 inches on top. Almost every house I've ever gone into has stuff sitting on top of their ETS heaters. And once in a while, you'll see purple streaks down the front of the heaters where the candles have melted and run down the front of the heater. Just make sure you're talking to your customers about that they shouldn't be setting stuff on top of the heaters. I know people love to sit on them. Again, it does violate the clearance, but we know it happens all the time and happens in lots of our houses and offices as well. So where should you put the heater? Interior walls versus exterior walls? Our official answer to that is it should be on an interior wall that's adjacent to the exterior wall. And the reason we say that is because the cabinets get warm and that heat will transfer in the wall behind it. So if the heater is placed on an exterior wall, you're going to have some amount of heat loss that goes to the outside. It's generally pretty small, but on a frosty day, if you drive past somebody that's got ETS heaters on the exterior walls, you can actually see an outline of where those heaters are. So there is some amount of heat that goes outside. That all being said, when people ask me about where they should go, my response is where the homeowner wants it. When you're looking at the layout of the room, what makes sense for the homeowner. We've certainly seen that there's been electrician will say, well, it's easy to run wire here, so we should put that heater here. But if the homeowner doesn't want it there, let's not put it there. And certainly we'd hate to lose sale if it was something with the aesthetics of where we wanted to place the heater. So again, I would typically say you want to put it where the homeowner wants it. Other things to be careful of in terms of placement is that we sense room temperature on the right-hand side of the heater. So if you only have 2 inches of clearance there, you're going to need to use one of our remote mount room temperature sensors, which is just a low voltage connection to a sensor that's away from the heater. Other times you might want to use that is if the heater's next to something that causes sources of heater cold. Where I've seen that is when the heater's been next to like a patio door, where we've seen that there's some cold air that pools around that right-hand side, and the heater runs more than the homeowner wants. Again, in those kind of applications, you want to use a remote mount sensor. So common applications for the room heaters, perfect for retrofit applications if you're replacing some other kind of heating system. Supplement to baseboards, and we'll talk a little bit more about that. Wood stove replacement. Homes where there's no duct system in place. Over the years, we've seen a lot of ETS systems go where there were cabins and maybe seasonal cabins, and they didn't have heating systems, and now they want to make it a 12-month of a year kind of a place, and so we've sold a lot of ETS heaters into those kinds of places. Cold spot heating is another one. I like to use my house as an example. I have one of our forced air systems with a heat pump for doing the main heating system. But my lowest level, I just can't get enough heat down there with that forced air system. So I have a room heater there to help with that. Other places that applications where we've seen them get put in is where you have like a 4-season porch or an addition on the house and you can't get ductwork to it. Room heaters can do a nice job in those kinds of places. And of course, you don't have ductwork, so you don't have to worry about it. I just love this slide, so I keep it in my presentations. Okay, so one of the options is homes that have standard resistance heat and they're looking to heat more affordably, allowing getting onto a time of use or an ETS rate will certainly allow that to happen. So very common application. We put in 1 or 2 room heaters into the main areas of the home. We leave the baseboards in the kind of peripheral areas, the bedrooms and back areas, and try to do as much work as we can with the ETS heaters, and only use the baseboards or other kind of resistance heat when it is needed. That does, gets the homeowner on that lower cost rate, but also helps at the utility to reduce that peak demand. And of course, it can deliver better comfort because now the homeowner can keep the house at a comfortable temperature when they're because they have that lower rate, they can keep their costs down. Manufactured homes. So there's the application that's just like any other standard stick-built home or any other kind of home that works. But in areas that have a lot of manufactured homes that are electrically heated, those can be a challenge for utilities because you typically have electric furnaces, might have heat pumps with them, but on those coldest days, the electric resistance is probably going to run. And what we've seen on those homes is that typically they'll add 10 kW to the overall load for the utility. So as a utility, if you're paying a demand rate to your G&T of say $20, and every month you're getting hit with that 10 kW, that's $200. That's a hard thing to get back and just selling with kWh sales. So trying to control that load. Over the years, we've had some really successful projects that we've done with mobile homes where we put one room unit in and control that electric furnace during the peak times and allow the EPS heater to do the heating. It can be a really nice application that has really good financial implications for the utility. Replace wood burners. When people are 20 and 30, they like to go out and cut wood and have that nice warm fireplace. As they start getting older, that appeal kind of rubs off and not that exciting anymore. So they're looking for ways, how can they affordably heat their home? And a room heater does a nice job with that. And it can be really nice in that it heats in a similar way where you're heating the main area of the house. You have this nice warm cabinet that you can go to, like if you have a nice fire going, you come in from outside and you can warm up next to either room heater. So that's people that have done this kind of thing have really been happy with that replacement. And of course, from a utility standpoint, it's good because you're going to get the kWh sales for that. All right, so that's our room heaters. Now we'll move on to our central systems. Our 4100 series are our forced air systems, and our 5100 series are our hydronic systems. Our hydronic system has the ability to do some forced air as well, and we'll talk about that. And those systems are all set up to be run along with air source heat pumps. So we'll talk about how that works as well. So when we look at the 4100 series, we always have a return on one side and supply on the other, but they can be set up either way. We can do upflow or downflow, and we'll talk a little bit about that. The supply air blower is a separate piece, so that's important to know when you're looking to purchase that you make sure that you get the appropriate blower. So we do have different blowers. We have a half horse, which was good up to about 1600 CFM, and then a 3/4 horsepower blower system that's good for 2000 CFM. Return air plenum is a option that you can get from us. We have a downflow kit, so if you're going to do downflow, we also have a stand if you want to pick the unit up off the floor. It's 18 inches, and we'll talk about some of those applications as well. So placement, things that you need to be at least aware of is weight. A big furnace is going to be 4,000 pounds, and so you need to make sure that the floor can handle that. If it's going in on a concrete slab in somebody's basement, it's just not an issue. But if you're going to put it on a wood floor that's second floor, third floor, whatever, you just need to make sure that the floor can handle it, and is probably just distribute that weight a little bit by putting something underneath the furnace to help do that. Room size with our Comfort Plus, if you look in our documentation, we talk about it being wanting 100 square feet in that room, in the mechanical room. And the reason for that is that the cabinet will get hot, and we want to make sure that we're able to deal with that heat and not overheat the area. On a forced air system, it's really not that much of an issue because we do circulate air over the top of the cabinet. So we're circulating air between different layers of metal in the furnace, and we'll take any static heat and put it in the ductwork. When we talk about 5100s, we don't have that ability, or so we need to deal with that. Again, clearances, it's something that's important, that we make sure we're talking to our homeowners about. The tops of these things look like shelves, and people like to store their Christmas decorations on top of them. So I would certainly, just if you see that in somebody's home, encourage them not to do that. Keep the area around the furnace as clean as possible. All right, so the 4100s can really be set up as with 3 different configurations. It can be just the sole standalone furnace, so it's just a heating appliance by itself. You can connect it with an air conditioner, or the one that we really like to encourage is using it along with an air source heat pump. And the reason that we like heat pumps is they can get better than 1-to-1 efficiency, and so you can get lower kWh usage from the house. However, heat pumps typically don't work real well as the temperatures get colder, and they don't have enough heat to heat the overall space, and or they, when you get too cold, they don't run at all, and so you need to have something to back it up. And so our furnace can do a nice job of that. And so how our system works is that we circulate the air through the return, and we put the coldest air through the heat pump first. So we let the heat pump do as much work as it can. We monitor the discharge air, and if it's not warm enough, we'll start to circulate our core blower, which will extract heat from the bricks, put it into the discharge air to maintain comfortable air temperatures. And so that's a real nice system that people like, the fact that we're not blowing that cool air around in the house and making it drafty. So as I mentioned, combining the ETS heater along with an air source heat pump, you get the high efficiency of the heat pump plus the low cost of being on an off-peak rate to give you the most economical heating and cooling system available. And we see, combined efficiencies of 200% or even higher in some applications. So that's like I said, real nice system. Benefits both the homeowner, and again, by making sure that we're not on during the peak times, benefits the utility as well. So just to recap on our forced air systems, that we're going to make sure we ensure comfort. We're going to eliminate heat pump cool discharge air temps, provide supplemental heating as needed, and give operating costs comparable to that of a ground source heat pump, but at a more affordable initial investment. And if people have questions about that, we can certainly talk about those economics as well. All right, so that's our forced air system. How are we doing on time? Oh, we're all right. We'll look at our 5100 series, our hydronic system. So with this system, we're going to provide hot water to the home. And I get asked a lot, well, how does that work? You guys are getting those bricks up to 1200 degrees, and how are you able to keep the water liquid and not make it steam? Well, how we do that is by using a heat exchanger. So how the system works is when there's a heat call, we circulate water through a heat exchanger. We monitor the discharge water temperature, and we use our core blower to extract the heat out of the bricks and put it into the water to maintain whatever our setting is. And those settings can be anywhere from 90 degrees or even lower, all the way up to 180 degrees. And that would change depending on what your applications are. So in a system that we've You know, we can do any of the hot water kinds of heating system. When we started doing this, it was back 15, 20 years ago already, when there was a lot of new homes that were getting put in with in-floor tubing. So certainly we can do in-floor heating. You know, lots of old houses out there that have baseboard heating in them, hydronic heating, and we can certainly do those. In certain areas, a real common application is to remove the fuel oil boiler to replace it with an ETS system for doing those kinds of baseboard or even old radiator systems. And then we can also use an air handler. We have an air handler option that can do heating. So real common application in new construction is in-floor tubing in the lower levels, but they want air conditioning, so they want to have a heat pump, they want to have ductwork, and so combining that the system with the hydronic with an air handler, we can combine that with an air source heat pump and do all the same kinds of comfort modulation we do with the forced air system with our air handler to provide heating for those upper levels of the home. So again, we can do, you know, that common install of in-floor and lower levels, forced air for the upper levels. And of course, people love in-floor heat and always puts a big smile on their face. Some of the other applications, you know, underfloor tubing, we can certainly do that. Slab on grade, basically any kind of hot water hydronic system, you know, we can provide, like I said, up to 180 degrees, and we can lower that down. So if you were just doing in floor and you only need 90 degree water, we can do that as well. So I mentioned that we have programmable water temperatures. We also have outdoor reset. So as the temperatures get colder, we can increase our water temperature. That's real nice in an application where we're doing in-floor heating. And we also have what we call pump tickling, which just means that in the summertime we run the pumps every hour just to make sure that they don't seize up. So one of the applications we have is people say, can we put them in the garage? And we have lots of them in garages. The only thing I would caution there is the bottom 18 inches of the garage is considered a hazardous location by the National Electric Code. So you have to have electric switches and other things up above that 18 inches. So that's why our stand is 18 inches high. And so you can, if you're going to do that, you can buy our stand and pick the heater up off the floor. One of the most expensive and complicated parts of a hydronic system can be the control system that goes along with it. You have multiple pumps, multiple zones, and add an air handler on it, and that can add to a lot of complexity. We have the ability to run up to 3 pumps with our system, and we have the ability to take the heat call signals from either zone valves or from thermostats directly, so we can control many different things. So in a common residential application, you don't need any auxiliary controls, like pump controllers or zone controllers. That can be handled through the Steffes systems and save some money there. Other things we get asked about, can you put multiple 5100 series in the same system? And the answer is yes. In a really big house, you might have 2 of them. Typically, we don't have 4, but it is possible if you have the need. You can also put it along with a gas boiler. So, it might be that you're limited at the house to by the amount of electrical service that's available. And so you're limited to the size of the Steffes heater you can put in, but you have a heat loss that's greater. We've had applications where people have put either a gas boiler or a propane boiler along with the Steffes heater to help out on those coldest days. All right, with that, it's kind of a quick overview of our residential systems. How are we doing, Allie?
Doing good. No questions have been submitted, so. But if anybody has questions later, they can always reach out to us and we can answer them then too.
Okay. Maybe people are typing feverishly right now.
Maybe. We can go to the next slide for now. If I see anything pop up, I'll let you know.
Okay.
Yeah, so thank you, Al, for that. So our next upcoming webinars, the next one, we did residential today. The next one, we're going to go over some commercial applications. And then after that, we're going to switch gears a little bit. On August 6th, myself and Kaylee, our marketing manager, we're going to go over some of our marketing and sales materials that we have, some messaging, advertising, things like that we have available. And then on August 20th, I think Julie is going to go over our tech resource library and talk about all different resources available there. So the next newsletter is going out next week, and the signups will be, the next two webinars will be in that email. So look for that. Other than that, I think that's it for today. If nobody has anything else, thank you for joining us. We'll see you next time.
Thank you.